All right, hey, this is Horner, and this is the 2001 number 1 AP Physics C Mechanics question. So a motion and a force sensor, both are here, and they record the motion of the cart along a track as shown. The cart is given a push, so it moves towards the force sensor, and then collides with it. The two sensors record the values shown in the above graphs. So when the cart gets over and touches this, that's when you start to see the force go up, and then it will move back and you see the force come back off of it. We can tell that the velocity is pretty positive, and then when it hits this, it goes back negative. So you'll see that it's 0 at this 0.35 seconds. That's when you have peak force, and then when it moves away, you'll notice that it backs back off again, the force does. So they want you to determine the cart's average acceleration between the time 0.33 and 0.37. So notice that I have a force in time and a velocity time. If I want average acceleration, velocity divided by time is a meter per second, which is acceleration. So that's essentially what we want to do. First thing we're going to do here is find the delta t, the change in time. That essentially is just your 0.37 minus 0.33. So your change in time here is 0.04 seconds. From the graph, we see that our initial velocity is somewhere around 0.22 meters per second. So this is going to be a guessing game, and so there's a wide range of answers. They took anything from 0.20 all the way up to 0.25. The final velocity, their official answer that they gave here was negative 0.18 meters per second. You couldn't tell that here, so they gave a range of negative 0.15 to negative 0.2. Now that they've done that, we can do our change in velocity. So that is the final, which is negative 0.18 meters per second minus 0.22 meters per second, and that gives us negative 0.4 meters per second. So notice you're actually adding the two together because you're going to get a big change here. Now that we've done that, we can go ahead and find the acceleration. So the acceleration here is equal to change in velocity all over the change in time. So that's going to be equal to negative 0.4 meters per second. And we're going to divide that by 0.04 seconds. And you get negative 10 meters per second squared. Interesting, isn't it? So that is all of your work. Where do all your points come from? So you get 1 point for doing the subtraction. You get 1 point for doing or picking the right number there, 1 for picking the right number in the range here. You also get a point for finding delta V. You get a point for doing all this math, and then you get a point for the negative sign. And the negative sign is important because it shows it's decelerating. So you also get a point for that negative sign. So I thought that was pretty interesting. Lots of points here. 5 points for that very first, actually 6 points for that very first part. So 1, 2, 3, 4, 5, 6. They want to next have us find the magnitude and the change of the cart's momentum during the collision. If we remember, the change in momentum is really impulse, and impulse is equal to m delta v. But more importantly, it's equal to F times the change in time. So we're basically asked to go through and find out what is the area underneath here. So you could just go through and try to find it graphically, which would be a real pain, or you can go through and you can do this. If you find the area under the curve, that's probably the easiest way to do it. It's kind of goofy, but you can do that really easily. You actually have a pretty nice almost triangle here. You do have this triangle right here. So we can find the area of each side. Once you know the areas of each side, then you can find the area of this box and then take that and divide it by 2, because notice that this is really half of a box here. Find this box, half of it, and then add everything together. If you do that, you should get a value of about 0.6. So one thing that you have to do is you have to say delta P is equal to the integral of f dt. If you don't do that, you could also say delta P is equal to area of f versus t curve. So now you just need your number, delta P, change of momentum, is equal to 0.6. You need to have a unit, and it's either a Newton times a second from force times time, or you could have 0.6 kilogram meter per second, which is what we typically see in momentum. So that is worth 3 points. You have to have the right unit, you have to have the right answer, and then you have to indicate what you're doing. For letter C, this one says determine the mass of the cart. So if I want to know the mass of the cart, I know that the change in momentum is equal to mass times the change in velocity. Mass then would be equal to the change in momentum, which is the impulse, divided by that change in velocity. We've already found the impulse to be 0.6. We found the change in velocity to be 0.4. If you do a kilogram meter per second here, and this is a meter per second, and then these cross off, we're left with kilograms, and 0.6 divided by 0.4 is 1.5, and our unit is a kilogram. So you get 1 point for showing this, and 1 point for showing this. So far pretty easy. Next thing that they want us to do is find the energy lost between the sensor and the cart. So to do that is really not too bad. So for this one, probably the easiest thing to do, and by the way, there's a million ways to do C. That's just one of them. That's probably one of the easier ways to do it. But let's go ahead and do D. And if we do D, if we go through and kind of take a look at D, here we've just got the change in energy should be equal to the final energy, EF, minus our initial energy. Our energy here is equal to 1/2 mv squared because it's moving, and so that's our kinetic energy. We know that we've got a couple of those, so our change in energy is just going to be the difference in the kinetic energy. And so we can plug everything in. This is 1/2 of 1.5 was our mass. Our final speed was 0.22 squared minus our original, which is 1.5 times negative 0.18. And we're going to square that, and if you do all your math, you should get 0.012 joules. And the points come from just showing this energy change for having a kinetic energy equation. So if you only had that much, they would give you points. For substituting all your values in and then getting an answer, and then they did one more for units. And that is the end of this problem.